Alright guys, so here we have a piston cylinder assembly containing 1.5 pound mass of gas undergoing thermodynamic process 1 to 2. After completing the process, the specific internal energy decreases from an initial U1 equals 1360 BTU per pound mass to a final U2 equals 990 BTU per pound mass. Also, the heat transfer during this process, Q12, is 345 BTU, and we have to find the amount of work done by the system during this process, W12, and it's going to be in BTU. So the way I like to start out every thermodynamic problem is to write out what all of my givens are and what I'm looking for. So just a quick reiteration here, we have the mass as 1.5 pound mass, the specific internal energy before as 1360 BTU per pound mass, and after as 990 BTU per pound mass. We have the heat transfer as 345 BTU, and we're looking for the work. Alright, so let's apply the first law of thermodynamics. So we have delta E is equal to the heat transfer minus the net work. And this is all over process 1 to 2. We can break down the first law, and we know that the net change of system energy can be equal to the potential energy plus the kinetic energy plus the change in internal energy. And that is going to be equal to the heat transfer minus the net work. So we don't have any potential energy, so we can cross that out, and that's a 0. We can cross out the kinetic energy, same thing, we don't have that, and that's a 0. And we're left that the internal energy, the difference in internal energy, rather, is equal to the heat transfer minus the net work. So now we can break this down, and we know that U2 minus U1 is going to be equal to the heat transfer minus the net work. However, it's critical that you notice that here we're dealing with bulk form, so because we're using capital letters, these units here on the right are going to be in BTU. For example, over here we would have 345 BTU for Q, and the work we're going to solve for, and that's also actually going to be in BTU. I should have mentioned that up here. But we're not actually given the internal energy in BTU. We're actually just given the specific internal energy. As you can see, we're given a lowercase letter here of BTU per pound mass. So simply to get from here to here of a specific to a bulk form, all you have to do is multiply by the mass. So we could rewrite this equation over here, and we have the mass times the specific internal energy, or the difference in specific internal energy of this process, is equal to the heat transfer minus the net work. So now we can just solve for the work, and we have that the work, W12, is equal to the heat transfer minus the mass times the change in specific internal energy. Now it's just simple plug and chug. We have the work, the net work, is equal to 345, and we're going to write the units in here, BTU, minus the mass is 1.5 pound mass, times the change of internal energy is 1360. I'm sorry, 990. So it's 990 is actually U2, BTU, per pound mass, minus 1360 BTU per pound mass. Alright, so now we can multiply the units across, and we have a BTU on the left here, and then we have a pound mass over here, so we can't do arithmetic with those. So all we have to do is cross out that pound mass times these pound mass, and now as you can see, you're left with BTU, and from it you're subtracting BTUs. After you plug this into your calculator, you'll have that the work, W12, is equal to 900 BTU. And because that number is positive, a positive 900 BTU, we know that the work is done by the system.